So 11.3 goes over the inverse of a matrix. There's a couple things that you're going to do with this section. You're going to find the inverse of a matrix, and you're also going to tell whether two matrices are inverses or not. When you represent an inverse of a function, you see it as f to the negative 1 of x. You're going to simplify these the same exact way, but when you do that, you're going to represent those inverses using a to the negative 1. So inverse function or inverse notation is represented with a to the negative 1. Okay. When you look at these, the first thing that we're going to do is to tell whether two matrices are inverses. When you do that, you're going to look for a times b, and then you're going to look for b times a. When you find a times b and when you find b times a, you should be left with the matrix of 1, 0, 0, 1 if they are inverses. And this is both for a times b and for b times a. Okay, so the first thing that we're going to find, given these two matrices, which are a is equal to negative 1, 2, negative 1, 1, and b is equal to 1, negative 2, 1, negative 1, is we're going to find a times b. So a times b is what we'll find first. A we have as negative 1, 2, negative 1, 1. B we have as 1, negative 2, 1, negative 1. So to find your multiplication out of these two, you have a 2 by 2 by a 2 by 2. So that means that your answer is going to be a 2 by 2. And you can multiply these. If you're going first row, first column, you're going to have negative 1 times 1, which is negative 1. Then you'll have 2 times 1, which is 2. That's going to give you a 1. Next, I'm going to go top on the right. So first column, first row, second column, you have negative 1 times negative 2, which is 2. Then you have 2 times negative 1, which is negative 2. That simplifies and gives you 0. Next, we're going bottom row by first column. So that's negative 1 times 1, which is negative 1, and 1 times 1, which is positive 1. That simplifies and gives you 0. Lastly, bottom row, second column. So negative 1 times negative 2 is 2. 1 times negative 1 is negative 1. That simplifies to give you 1. That's leaving you with the 1, 0, 0, 1 that you're looking for. But you still have to find for b times a. So that means you're going to do negative 1, 2, positive 1, negative 2, 1 and negative 1, times negative 1, 2, negative 1, 1. So again, your answer for this one is going to be a 2 by 2. Top on the right, first row, first column, 1 times negative 1 is negative 1. Negative 2 times negative 1 is positive 2. That gives you 1. Top row, second column, 1 times 2 is 2. Negative 2 times 1 is negative 2. Those add to give you 0. Bottom row, first column, 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. So that gives you 0. Lastly, bottom row, second column, 1 times 2 is 2. Negative 1 times 1 is negative 1. 2 minus 1 is 1. So those both give you exactly what you're looking for with those matrices of that 1, 0, 0, 1. So these two are inverses of one another. The next part within this lesson goes over finding the inverse of a 2 by 2 matrix. By doing this, there's two different ways of doing it. You can use the formula that you have here, which is the a to the power of -1 is equal to 1 over a times d minus b times c, and then multiply that by d negative b negative ca. You can use that, or you can first find a times d minus b times c, and then you can switch your a and your d and switch the signs on b and c and multiply your inverse of AD minus BC by that. I choose to do it that way because it's not as much work to write down, but it's your choice, whichever one you'd like to use. Okay. For example 4a, you're finding the inverse of 3, -1, -2, 2. So first thing we're going to do, I'm going to label A, B, C, D. I'm going to find AD minus BC. So that's 3 times 2 minus -1 times -2. 3 times 2 is 6. The -1 times -2 is +2. 6 minus 2 is 4. The inverse of 4 is 1/4. So we're going to switch A and D. We're going to change the signs on B and C, and we're going to do 1/4 times the matrix of 2, 1, 2, 3. So this is going to give us A to the -1 is equal to the matrix of 1/2, 1/4, 1/2, and 3/2. Or sorry, 3/4. And that would be your answer. For example B, you're given the matrix 3, -1, -6, 2. So first we're going to find A times D minus B times C. A is 3, D is 2, B is -1, C is -6. So that's going to give you 6 minus 6, which is 0. The inverse of 0 is 1/0. If you multiply that by switching your A and your D, changing the signs on B and C, that would give you 2, 1, 6, 3. Can you multiply by a fraction with 0 in the denominator? Nope. So this one does not have an inverse. Anytime you have 0 in the denominator, it is undefined, which is why we can't multiply by this. For your last example, C, you have the matrix of 1, 4, -1, -3. So first thing we're going to do is find AD minus BC. So that's going to be 1 times -3 minus 4 times -1. The 1 times -3 is -3. The 4 times -1 is +4. So -3 plus 4 is 1. Take the reciprocal of that 1. That's 1/1. You're going to multiply it by changing the sign on changing the sign on B and C, switching your A and D. So it's going to be -3, -4, 1, 1. Everything stays the same here. So your A to the power of -1 is equal to the matrix -3, -4, 1, 1. Like we just said, this is part of your review for your quiz for 11.1 to 11.3. You're given that A is equal to -3, -1, 0, 2, -5, 4. B is the matrix -1, 3, 2, -4, 5, 8. And then C is the matrix -2, 1, -3, 6, -5, 2. First one you are finding is 2A minus 4B. So 2A would be 2 times -3, -1, 0, 2, -5, 4, minus 4 times B, which is negative 1, 3, 2, negative 4, 5, 8. First off, you multiply the 2 in, that's going to give you negative 6, negative 2, 0, 4, negative 10, 8. If you multiply the negative 4 in, that turns it into a positive. In between the two, you're going to change the sign on everything inside that second matrix. That's going to give you 4, negative 12, negative 8, 16, negative 20, negative 32. Look at what you have here. You have a matrix that's a 2 by 3 and a matrix that's a 3 by 2. When you add or subtract matrices, they have to be the same exact dimensions. These are not the same, so you cannot add. For your next example, you're multiplying A and C. So that is the matrix of negative 3, negative 1, 0, 2, negative 5, 4, times C, which he said is negative 2, 1, negative 3, 6, negative 5, 2. In order for you to multiply, you need to make sure that your dimensions have two numbers in the middle of them that are the same. You're multiplying a 2 by 3 by a 2 by 3. These two numbers here that fall in the middle are not the same, so you cannot multiply this. For your next example, we are finding 3A minus 5C. So we said that A is negative 3, negative 1, 0, 2, negative 5, 4, and C is the negative 2, 1, negative 3, 6, negative 5, 2. So we're going to multiply these numbers in. 3 times negative 3 is negative 9. 3 times negative 1 is negative 3. 3 times 0 is 0. 3 times 2 is 6. 3 times negative 5 is negative 15. 3 times 4 is 12. We're going to distribute the negative in with the 5, so I'm going to change this to addition. And we're going to have 10, negative 5, 15, negative 30, 25, and negative 10. So we're adding these. So same position in each, we'll add those numbers. So top left, top left, the negative 9 plus the 10 gives us 1. Middle on the top on both, negative 3 plus negative 5 is negative 8. Top right on both, 0 plus 15 is 15. Bottom left on both, 6 minus 30 is negative 24. Middle bottom on both, negative 15 plus 25 is 10. And bottom right on both, 12 minus 10 is 2. So we have the matrix 1, negative 8, 15, negative 24, 10, 2. For your last example, you have A times B. So we're going to do negative 3, negative 1, 0. What did we say that was? 2, negative 5, 4 times 1, negative 1, 3, 2, negative 4, 5, and 8. So look to see if you can actually multiply these together first. You have a 2 by 3 times a 3 by 2. The two middle numbers are the same, so use your outside numbers to know what kind of matrix you're going to have as your answer. The outside numbers you have are 2 and 2, so that's going to be a 2 by 2 for your answer. So top left, go first row by first column. Negative 3 times negative 1 is 3. Negative 1 times 2 is negative 2. 0 times 5 is 0. You got 3 minus 2, which is 1. For your next one, you're going top and right. So you're going first row, first column. So -3 times 3 is -9. The -1 times -4 is +4. 0 times 8 is 0, so that gives you a -5. So next one you got is bottom and then top and first row. So 2 times -1 is -2. The -5 times 2 is -10. The 4 times 5 is 20. That's going to give you the -12 plus 20, which is 8. And then your last one is bottom row, second column. So 2 times 3 is 6. -5 times 4, -4 is +20. And 4 times 8 is 32. So that gives you 52 plus 6, which is 58. Other than your adding, subtracting, and multiplying with these matrices, the other things that are on your quiz, you're going to see inverses, telling whether or not two matrices are inverses. You're also going to see find the inverse of the given matrix. You need to be able to tell the dimensions of a matrix, so row by column. You're also going to have to be able to write the system of equations given the matrix. And then solving for x, perform the operations, which is exactly what we just did. So an example with write the system given the equation, or write the system of equations given the matrix. If you're given the matrix of, let's say, 2, 0, 8, -3, 1, 3, -4, let's go 5 there. Let's do 6, -7, 0, and 2. To write the system given this, remember, these are your x, these are your y's, z, and then your answers. So that means you have 2x, you don't have a y for that one, plus 8z is equal to -3. Then you have x plus 3y minus 4z is equal to 5, and 6x minus 7y, you don't have a z on that one, is equal to 2. So that would just be the system. What's in orange would be your system given the matrix that's there.